Hello everyone, in this video we're going to review AP Calculus BC topic 9.7 through 9.9 polar curves. Alright, so you need to know the formula S equals R cosine theta, Y equals R sine theta. And then if you square both sides, it's going to be S squared equals R squared cosine square theta, and this one y square equals r square sine square theta. Now if you add them up, you're going to end up with s square plus y square equals r square. So keep this one in mind, right? Now if you need to find the slope of the tangent line dy over ds, you need to divide the top and bottom by d theta, and then you need to calculate the derivative of y and s with respect to theta, right? So this formula you need to remember. Now, in order to find the error enclosed by a polar curve, we're going to use this formula. A equals 1/2 integral from a to b r squared d theta. Alright, now look at this example right here. A equals 0, B equals 2 pi, right? The radius is right here. And we just plug this one into the formula, we get the answer, right? Now, the error between two polar curves, we're going to use this formula. The error equals 1/2 times the integral from A to B of the outer radius square minus the inner radius square d theta. Alright, now let's take a look at the first question. Which of the following is equal to the error of the region inside the polar curve r equals 2 cosine theta and outside the polar curve r equals cosine theta? Now, you're not allowed to use the calculator for this question, so basically you need to know how to sketch this one by hand. Alright, so how do I know it? Now I'm going to start with this guy first, right? So I'm going to multiply both sides by r. So I have r squared equals 2r cosine theta, right? Remember you have s squared plus y squared equals r squared, right? You have s equals r cosine theta, right? You have y equals r sine theta, right? So keep this one in mind. So r squared is going to be s squared plus y squared equals 2 r cosine theta is going to be s, right? Now I'm going to subtract 2s both sides, so it can be s squared minus 2s plus y squared equals 0, right? Now I need to do complete square, right? So I'm going to take 2 right here, the middle term right here, divide by 2 and square is going to be 1. So I'm going to add 1 both sides, right? So the first 3 terms right here is going to be complete square formula, right? So s minus 1 r together square plus y square equals 1. Now remember the circle equation is going to be s minus h r together square plus y minus k r together square equals r square, right? The center is going to be h and k. The radius equals square root of the number on the right hand side, which means r squared right here, right? So this guy has the center is going to be 1, 0, right? And the radius is square root of 1, which means 1, right? Similarly, I have r equals cosine theta, right? Multiply both sides by r, so it can be r squared equals r cosine theta, right? So it can be s squared plus y squared equals s, right? So it can be s squared minus s plus y squared equals 0, right? Now take the middle term right here, it's going to be 1 divided by 2 and square. So basically you just add 1/4 both sides, right? So this guy becomes s minus 1/2 r together square plus y square equals 1/4, right? So you have the center is going to be 1/2, 0. And the radius is going to be square root of 1/4 is going to be 1/2, right? Now we're going to sketch this one, so it could be something like this. The radius for the smaller circle is going to be 1/2 right here, right? The radius for the bigger circle is going to be 1 right here, right? Now we're going to use the formula, the error equals 1/2 the integral from a to b of the outer radius, I'm going to call this a bigger radius square, subtract the inner radius, which means the smaller radius square, d theta, right? Now the outer radius is going to be this one right here, right? The inner one is going to be this one right here, right? Now remember that both circles right here trace from negative pi over 2 to pi over 2, right? So it's going to be 1/2 integral from negative pi over 2 to pi over 2 of this guy square is going to be 4 cosine square theta, right? Subtract this guy square is going to be minus cosine square theta d theta, right? So it's going to be 1/2 integral from negative pi over 2 to pi over 2 of 3 cosine square theta d theta, right? You have two portions right here. I call this A1, A2, right? They symmetric about the polar axis, right? So you just calculate the upper one and you multiply by 2, right? So the upper one is going to be from 0 to pi over 2, right? So I have the error is going to be 2 times 1/2 integral from 0 to pi over 2, right? 3 cosine square theta d theta. And I'm going to simplify this guy cancel out. So I'm going to end up with this guy right here, right? So the answer must be A. Now let's move on to question number 2. This is not a calculator active problem. This question comes from AP Calculus BC question 19 in 1998. Alright, the area of the regions inside the polar curve is this guy and outside the polar curve is this guy. Alright, r squared equals 4r sine theta, right? Now this one is turned out to be x squared plus y squared equals 4y, right? So then it's going to be x squared plus y squared subtract 4y equal to 0, right? Now I need to do complete square. So basically I look at the middle term here, 4 divided by 2 is going to be 2 squared, it's going to be 4. So I'm going to add 4 both sides, right? So this guy becomes x squared plus y minus 2 altogether square equals 4, right? So the center is going to be 0, 2. And the radius is going to be 2, right? Now similarly, this one is the circle with the radius 2. And the center is going to be origin, right? So if you sketch this figure, it's going to be something like this, right? And observe that this region is symmetric about the y-axis, right? So you just calculate the area of one region and you multiply by 2, right? Now first, I need to find the intersection between this guy and this guy, right? So I just equate this guy and this guy, right? So I have 4 sine theta equals 2. So sine theta equals 1/2, right? And theta equals pi over 6 and 5 pi over 6, right? Now you have the formula, error is going to be 1/2. The integral from pi over 6 to 5 pi over 6, right? The outer radius, right? The outer radius is this guy right here, right? So you have 4 sine theta altogether square, subtract the inner radius. The inner radius is right here, 2 square d theta, right? It's going to be 1/2 integral from pi over 6 to 5 pi over 6, 16 sine square theta subtract 4 d theta, right? So the answer must be D. Now let's move on to question 3. Calculator is not allowed for this question. This question comes from AP Calculus BC question 26 in 2008. Which of the following expression gives the total error enclosed by the polar curve r equals sine square theta shown in the figure above. Alright, so it's going to be this region. Now observe that these two regions right here is symmetric about the polar axis. So basically you just calculate the area of one section and you multiply by 2, right? Now you need to find the lower limit and upper limit, right? So you see that at the origin the radius equals 0, right? So you're gonna let radius equals 0 is the same thing as sine square theta equals 0, right? And then it's going to be sine theta equals 0, right? Theta equals 0 and pi, right? So the lower limit is 0, the upper limit is pi. So you have the error is going to be 1/2 integral from 0 to pi, right? The radius square, so it could be sine square theta all together square d theta, right? Now you need to multiply this guy by 2 to get both sections right here, right? So you have 2 times this guy to get the top and the bottom. Now we're going to simplify. It's going to be integral from 0 to pi sine to the 4 theta d theta, right? Because this guy cancel out, right? So the answer must be D. Now let's move on to question 4. Calculator is not allowed for this question. Alright, what is the area of the regions enclosed by the limit scale? R squared equals 18 cosine 2 theta, shown in the figure below. Alright, so again, at the origin, the radius equals 0, right? So we need to let the radius equal to 0 to find the lower limit and upper limit, right? So this square equals 0 is the same thing as 18 cosine 2 theta equal to 0, right? So cosine 2 theta equals 0 divided by 18, it could be 0, right? And then it could be cosine 2 theta equals cosine of pi over 2, right? So 2 theta equals plus and minus pi over 2, right? Remember, this is what you learned from AP pre-calculus, so make sure you review this concept, right? So divide both sides by 2, you have theta equals plus and minus pi over 4, right? So this one is negative pi over 4 right here. And this one is positive pi over 4, right? So the error is going to be these regions, right? So the error is going to be 1/2 the integral from negative pi over 4 to pi over 4 r squared. So it could be 18 cosine 2 theta d theta, right? This one already is square, right? Now you need to multiply this guy by 2 to get the one on the left hand side, right? So I need to put 2 right here, right? Now we need to review the old concept. If the function f(s) is even, then you have the integral from negative a to a of f of s ds equals 2 times the integral from 0 to a of f of s ds, right? If the function f(s) is odd, you have the integral from negative a to a of f of s ds equal to 0. So keep that in mind. Now the cosine function is even, right? So this guy cancel out. So this guy becomes the integral from 0 to pi over 4. And you need to put 2 right here, right? Of 18 cosine 2 theta d theta. So it could be 36 integral from 0 to pi over 4 cosine 2 theta d theta, right? And it's going to be 36 over 2 sine 2 theta evaluated from 0 to pi over 4, right? Now remember, if you have sine of as plus b, and then when you take antiderivative of this one, it turns out to be negative 1 over a cosine of as plus b plus c. Similarly, you have antiderivative of cosine of as plus b ds. It turns out to be 1 over a sine of as plus b plus c. If you have antiderivative of e to the as plus b ds, it turns out to be 1 over a e to the as plus b plus c. So keep that in mind. Right? So this guy turns out to be 36 divided by 2, it could be 18, right? Times sine of 2 times pi over 4, it could be pi over 2, right? Substitute 0 for theta, the bottom one should be 0, right? So the answer should be 18, right? Because sine pi over 2 equals 1, right? So the answer must be C. Now let's move on to question 5. Calculator is not allowed for this question. This question comes from AB Calculus BC question 23 in 1988. Which of the following gives the area of the regions enclosed by the loop of the graph of the polar curve r equal 4 cosine 3 theta shown in the figure above? Alright, so basically you need to find the lower limit and upper limit, right? So observe that at the origin the radius equals 0, right? So we're gonna let r equal to 0 is the same thing as for cosine of 3 theta equals 0, right? Divide both sides by 4, so cosine 3 theta equals 0, right? So cosine 3 theta equals cosine of pi over 2, right? So 3 theta equals plus and minus pi over 2, right? So theta equals plus and minus pi over 6, right? So the upper limit is pi over 6. The lower limit is going to be negative pi over 6, right? So the error is going to be 1/2 in row form negative pi over 6 to pi over 6, right? Of the radius square, so it could be 4 cosine 3 theta all together square d theta, right? Now we're going to simplify, so it could be 1/2 in row form negative pi over 6 to pi over 6. 4 square equals 16, right? So I put 16 outside, right? So it could be cosine 3 theta all together square d theta, right? 16 divided by 2, it could be 8. So it could be 8 in the row form negative pi over 6 to pi over 6 cosine of 3 theta all together square d theta, right? So the answer must be E, right? Now let's move on to question 6. Calculator is not allowed for this question. This question comes from AP Calculus BC question 24 in 1985. The area of regions enclosed by the polar curves for 0 to pi over 2 is, this is very simple, right? So you have A equals 1/2 in the form 0 to pi over 2, the radius square, right? So it could be sine square of 2 theta d theta, right? So we're going to use this formula. Sine square of theta is going to be 1 minus cosine 2 theta divided by 2, right? Remember, you have cosine square of theta is going to be 1 plus cosine 2 theta divided by 2, right? Now, since the angle is 2 theta, so if I put 2 right here, and this guy must be double, right? So it should be 4, right? This guy stay. Keep in mind, you don't double this guy, right? So this guy becomes 1/2 in row form 0 to pi over 2 of 1 minus cosine 4 theta divided by 2 d theta, right? Now 1/2 inside right here, I'm going to bring this one outside, so I have A equals 1 over 4, right? Now I'm going to take antiderivative of this one, it's going to be theta, right? Antiderivative of this one is going to be 1 over 4 sine 4 theta, and I have the negative side right here, so it could be negative 1 over 4 sine 4 theta, right? Evaluated from 0 to pi over 2, right? So it could be 1 over 4 pi over 2 minus 1 over 4 sine of 4 times pi over 2, it's going to be 2 pi, right? And if I substitute 0 for theta, it's going to be 0, so I don't need to worry about the lower limit, right? So this guy becomes pi over 8. This guy becomes 0 because sine 2 pi equals 0, right? So the answer must be D. Now let's move on to question number 6. Calculator is not allowed. Determine the slope of the line tangent to the polar curve r equals 1 plus 2 sine theta s, theta equals pi over 2. Alright, so remember you have s equals r cosine theta, right? So, but r equals 1 plus 2 sine theta, so it can be s equals 1 plus 2 sine theta times cosine theta, right? Now y equals r sine theta. So y equals 1 plus 2 sine theta times sine theta, right? Now the slope of the tangent line is going to be dy over ds, right? So I'm going to divide the top bottom by d theta. So you have dy over d theta divided by ds over d theta, right? So I'm going to take the derivative of this guy right here with respect to theta, right? So I'm going to use the product rule, right? So it could be 2 cosine theta times sine theta plus 1 plus 2 sine theta cosine theta, right? Over derivative of this guy is going to be 2 cosine theta times cosine theta. Derivative of cosine is going to be negative side, so it could be negative 1 plus 2 sine theta times sine theta, right? Now I'm going to substitute pi over 2 for theta, right? So dy over ds at theta equals pi over 2 equals cosine of pi over 2 equals 0, so this guy gone, right? Cosine of pi over 2 equals 0, so this guy's gone. So the top equals 0, the bottom. Cosine of pi over 2 equals 0, right? Sine of pi over 2 equals 1. This guy equals 1, right? So it could be negative 3, so the answer is 0, right? So the answer must be A. Now let's move on to question 8. Calculator is not allowed for this question. This question comes from AP Calculus BC question 5 in 1993. Which of the following represent the graph of the polar curve r equals 2 secant theta, right? So remember you have s equals r cosine theta, right? So then s equals r equals this one, right? So it can be 2 secant theta times cosine theta, right? But secant theta is going to be 1 over cosine, so it can be s equals 2 times 1 over cosine theta times cosine theta. This guy cancel out, so s equals 2. This guy actually the vertical line at s equals 2. So the answer must be D. Now let's move on to question 9. Calculator is allowed. This question comes from AP Calculus BC question 3 in 2003. Alright, the figure above shows the graphs of the lines s equals 5 over 3y. So we mean this one s equals 5 over 3y. And the curve C is given by s equals square root of 1 plus y squared, right? So this one s equals square root of 1 plus y squared. Let S be the shaded regions bounded by the two graphs and the x-axis. The line and the curve intersect at point P. Find the coordinates of point P and the value of ds over dy for the curve C at point B. So basically, we need to find the intersection between this guy and this guy, right? So we see that they both equal s, right? We just equate the right hand side, right? So we have, and then we're gonna square both sides. So it will be 1 plus y squared equals 25 over 9 y squared, right? 25 over 9 squared subtract y squared is going to be 16 over 9 y squared equals 1, right? Then y squared equals 9 over 16, right? Take square root both sides, so y equals plus and minus 3 over 4, right? Now since point P in the first quadrant, so the y value should be positive, right? So we only take y equals 3 over 4 is the final answer, right? Now we need to find ds over dy. We need to take the derivative of this one with respect to y, right? So remember, if you have the square root of u prime, it could be u prime over 2 square root of u, right? So this guy turns out to be ds over dy equals 1 plus y squared prime over 2 square root of 1 plus y squared, right? Now we're going to simplify. It's going to be 2y over 2 square root of 1 plus y squared, right? So it could be y over square root of 1 plus y squared, right? But square root of 1 plus y squared equals s right here, right? So you have ds over dy equals y divided by s, right? But y equals 3 over 4, so it could be 3 over 4 over. Substitute 3 over 4 over here to solve for s. So s equals 5 over 4, right? So substitute 5 over 4 over here. So you have 5 over 4. Multiply the top bottom by 4. So the answer must be 3 over 5, right? Now let's move on to question C. The curve C is a part of the curve x squared minus y squared equals 1. Show that x squared minus y squared equals 1 can be written as the polar equation r squared equals 1 over cosine squared minus sine squared theta, right? So we're going to start from here. We know that s equals r cosine theta, right? So we have r squared cosine squared theta minus y squared. Y equals r sine theta, right? So it could be r squared sine squared theta, right? Equals 1. And then I'm going to factor r squared out. So you have r squared times cosine squared theta minus sine squared theta equals 1, right? Divide both sides by this guy. So r squared equals 1 divided by cosine squared theta minus sine square theta, and this one has been proved. Now question D. Use the polar equation from part C to set up an integral expression with respect to polar angle theta that represents the error asked. So we know that the error equals 1/2 integral from A to B of radius square d theta, right? So we need to find the lower limit and upper limit first, right? So we're gonna go back over here, the region S right here. The lower limit is right here, right? It's gonna be 0. The upper limit is right here, right? We don't know it. We need to find it. And we know that the angle right here is gonna be theta, right? So we have the coordinate point P right here. We just draw the vertical line, right? So this one is the right triangle. Now we're going to use trigonometric ratio in the right triangle, right? So we have tangent theta is going to be opposite over adjacent, right? So I call this is B A, right? So it could be PA over OA, right? PA which means the Y value, OA which means the S value, right? And Y over S, we got it right here, 3 over 5. So this one is 3 over 5. Now we need to find the measure of angle theta. We're going to take inverse tangent both sides. So we have theta equals inverse tangent of 3 over 5, right? So this one is the upper limit for this guy right here, right? So I'm going to go back over here and substitute into this guy, right? So I have 1/2 integral from 0 to inverse tangent of 3 over 5. The radius square is going to be 1 over cosine square theta minus sine square theta d theta, right? Remember, it's right here, right? Now let's move on to question 10. Calculator is not allowed for this question. This question comes from AP Calculus BC question 2 in 2005. The curve above is drawn in the xy plane and is described by the equation in polar coordinates r equals theta plus sine 2 theta for theta from 0 to pi, where r is measured in meters and theta is measured in radians. The derivative of r with respect to theta is given by dr over d theta equals 1 plus 2 cosine 2 theta, right? Question A. Find the error bounded by the curve and the x-axis, right? So, we need to find the error of this region. Now, it's very simple. You just plug in the formulas, right? You have the formula A equals 1/2 integral from A to B, the radius square d theta, right? So you have A equals 1/2 integral from 0 to pi, right? Of this one square, theta plus sine 2 theta altogether square d theta, right? Now you're allowed to use the calculator, so you print up the calculator. Go to the home screen, press calculate, right? Press this button right here, put the integral right here, right? It's gonna be 0 to pi of x plus sine 2x altogether square dx. And don't forget to put 1/2 in the front, right? So it can be 0.5. And then press Ctrl Enter. It's gonna be 4.382. Now question B. Find the angle theta that corresponds to the point on the curve with x coordinate -2. Now remember, you have the formula s equals r cosine theta, right? But x equals -2, so you have -2 equals r equals this one right here, right? So you have theta plus sine 2 theta times cosine theta. Now you're gonna bring up the calculator. Add graphs right here, F1, which means -2, right? Press enter. Now F2, you're gonna press tab right here. So you're gonna put parentheses x plus sine 2x times cosine x. Now remember, you need to restrict the domain, right? Domain is going to be from 0 to pi, right? Which means 0 to 3.14, right? So you're going to restrict the domain. Press menu number for Windows setting right here. It's going to be from 0 to 3.14, so I'm going to put 3.2, right? And then press OK. It's going to be right here. Alright, so you have one intersection. So you're going to press menu number, set number 4. Go to the left, go to the right. The answer is right here. 2.79, right? Now, question C. For theta goes from pi over 3 to 2 pi over 3, dr over d theta is negative. What does this fact say about the radius? What does this fact say about the curve? Alright, so we have dr over d theta less than 0, right? So this one is the first derivative of the function of the radius, right? Less than 0, right? So it tells us that the function r of theta is decreasing on this interval. So we just answer this question. Now, when the radius is decreasing, it's getting closer to the origin, right? Now we go back to the graph right here. We can observe it. The radius is right here, bigger than this guy, right? So when the radius is decreasing, the distance from this guy less than this guy, and this guy right here getting closer to the origin, right? Now question D. Find the value of angle theta in the interval theta from 0 to pi over 2 that corresponds to the point on the curve in the first quadrant with radius distant from the origin. Alright, so when it's come to radius least or minimum or maximum, increasing or decreasing, think about the first derivative, right? So radius, which means maximum, right? And you given the closed interval right here, think about the candidate test, right? So first we need to find the derivative of the radius, right? dr over d theta is gonna be, we're gonna go back over here, the function r equals theta plus sine 2 theta, right? So it's gonna be d of theta plus sine 2 theta over d theta, right? Now we're gonna check the derivative of this one with respect to theta, right? So it could be 1 plus 2 cosine 2 theta, right? So this guy actually the first derivative, right? So we need to let this one equal to 0, right? So r prime equal to 0 is the same thing as 1 plus 2 cosine 2 theta equal to 0. Remember, we have the domain from 0 to pi over 2, right? So it's going to be cosine 2 theta equals negative 1/2, right? And cosine 2 theta is going to be cosine of 2 pi over 3, right? So 2 theta equals plus and minus 2 pi over 3, right? And then theta equals plus and minus pi over 3, right? Because theta between 0 to pi over 2, right? So we only pick theta equals pi over 3. That's it, right? Now we're going to use the candidate test. So we're going to sketch the table. Theta equals 0. It's going to be this value, right? Theta equals pi over 2. It's going to be the ending value right here. And theta equals pi over 3. This one is the critical number, right? Now substitute these three guys into the equation. R equals theta plus sine 2 theta, right? So theta equals 0 is going to be 0, right? Theta equals pi over 3 is going to be pi over 3 plus sine 2 pi over 3, right? So I'm going to bring up the calculator. You're going to go to calculator, right? So you're going to press home screen right here, go to calculate. Now it's going to be pi over 3. So you're going to press the fraction right here. Put pi over 3 plus sine of 2 pi over 3. And then press Ctrl Enter. It's going to give you the decimal number 1.913. Now theta equals pi over 2. We do exactly the same thing, right? So we're going to have pi over 2. And then you press Control Enter. It's going to give you 1.5708. Now, since we need the greatest distance, which means the maximum, so the answer must be this guy right here, right? So we need to say the greatest distance occurs when theta equals pi over 3. Now let's move on to the last question, question 11. This question comes from AB Calculus BC question 3 in 2007. Calculator is allowed. The graph of the polar curves r equals 2 and r equals 3 plus 2 cosine theta are shown in the figure above. The curves intersect when theta equals 2 pi over 3 and theta equals 4 pi over 3, right? So this guy right here, 2 pi over 3. This guy, 4 pi over 3, right? Let R be the regions that is inside the graph of R equals 2. And also inside the graph of R equals 3 plus 2 cosine theta, right? So this one is R right here. As shaded in the figure above, find the error of R. Observe that the region R includes two sections that symmetric about the polar axis. Now the one on the top traces from 0 to 2 pi over 3, right? This region right here enclosed by the inner circle, which means this one right here, right? And from 2 pi over 3 to pi right here, this region right here enclosed by the function right here, right? So we have A is 1/2 the integral from 0 to 2 pi over 3, right? Of the radius square. So this guy right here enclosed by radius equals 2, right? Look at this one right here. So it could be 2 square d theta, right? Plus this guy right here, right? The yellow one right here enclosed by the guys right here, right? So it could be integral from 2 pi over 3 to pi of 3 plus 2 cosine theta altogether square d theta, right? And then remember 1/2 multiplied by the whole thing right here, right? And then you need to multiply by 2 to get the bottom part right here, right? So 2 right here, right? This guy right here cancel out, right? So the integral from 0 to 2 pi over 3 of 2 square dx plus the integral from 2 pi over 3 to pi of 3 plus 2 cosine theta, and then press Control Enter. It's gonna be 10.3705, right? Now question B. A particle moving with non-zero velocity along the polar curve r equals 3 plus 2 cosine theta has position s of t, y of t at time t, with theta equals 0 when t equals 0. This particle moves along the curve so that dr over dt equals dr over d theta. Find the value of dr over dt as theta equals pi over 3 and interpret your answer in terms of motion of the particle. Alright, so we have dr over dt at theta equals pi over 3, right? Right here the question wants us to find this one, right? But this guy right here equal this guy, right? So we have dr over d theta at theta equals pi over 3, right? Now dr right here, so we need to take derivative of this one, so it's going to be negative 2 sine theta evaluated as pi over 3, right? So it could be negative 2 sine of pi over 3, right? We're gonna print up the calculator. So we have negative 2 times sine of pi over 3. And then you press Ctrl Enter. It's gonna be negative 1.732, right? Observe that this one less than 0, right? It tells us that the function r of theta is decreasing. So what does it mean? It means the particle is moving closer to the origin, right? Now let's move on to question C. For the particle described in part B, dy over dt equals dy over d theta. Find the value of dy over dt at theta equals pi over 3 and interpret the answer in terms of the motion of the particle. So remember we have y equals r sine theta, right? But r equals this guy right here, right? So we have 3 plus 2 cosine theta times sine theta, right? Now we have dy over dt at theta equals pi over 3, right? This is what we need to find right here. It's gonna be dy over d theta at theta equals pi over 3, right? Now we need to take derivative of this one with respect to theta, right? So we're gonna use the product rule, right? Negative 2 sine theta times sine theta is gonna be sine square theta, right? Plus derivative of this guy is gonna be cosine, right? So it's gonna be cosine theta times 3 plus 2 cosine theta, right? And we substitute pi over 3 over here. So we have negative 2 sine of pi over 3 all together square, right? Plus cosine of pi over 3 times 3 plus 2 cosine of pi over 3, right? Now we're gonna print up the calculator. So I'm gonna store the function y, right? So I'm gonna name this one as y of x. Hit Control the button right here, right? So I have 3 plus 2 cosine x times sine x, right? And I press Enter. So I'm gonna press the button right here, derivatives right here, right? With respect to x, and this one I just copy this one over here, and then I'm gonna press Control equals, put the line right here. I put x equals pi over 3, right? So I'm gonna put the fraction right here. Put pi over 3 and I press Control Enter. It's gonna give you 0.5, right? Now since this derivative is greater than 0, right? It tells us that y of theta is increasing. Then the particle is moving away from the x-axis. And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun. as she puts her hand in mine.